Hello, this is Mrs. Sargent, and this is lesson 7.2, Basic Stoichiometric Calculations. So you have this stoich map in your packet on lesson 7.2. You also would have got one of these in class. If you missed class, make sure you ask me for one when you return. First off, there's a couple of rules for stoichiometry problems. And I would write these down in the margin at the bottom of your page. The first rule is that you need a balanced chemical equation. Some of the times you're going to be provided with a balanced one. Other times you're going to need to balance it. So make sure that it's balanced before you start doing your calculations. Otherwise, you'll need to start over. The second rule is that in order to convert between two different compounds, you must switch at moles. And this is where the mole-to-mole ratio is going to come into place. So today, in this lesson, we're going to start with the bottom half of the stoich map. Only working from mass to moles to mass, or moles to mass, or mass to moles. Next time we'll talk about particles as well. So our first problem here, we have hydrogen gas reacting with oxygen to produce water. And so if you started with 1.9 grams of hydrogen gas, how many moles of water would you produce? I always underline what we're given, the number and the unit that we're given. And then I circle what do I want to find. So the unit I want to end up with is moles of water. So we're going to start with the 1.9 grams of hydrogen gas. And I'm going to take a look back here at our stoich map. We're given a mass, so this is where we're going to start here. This is going to be our grams of hydrogen. And then we want to go to moles of water. So we're going to go here to moles of H2O. This is going to be our end point right here. So anytime you are given a mass or you want to find a mass, you have to calculate the molar mass of that chemical. So we need to find the molar mass of hydrogen gas. So hydrogen's average atomic mass is 1.01. And then we have 2 atoms, so we're going to multiply that by 2. And that's going to give us 2.02 grams per mole. And remember, we can write the molar mass as 2.02 grams over 1 mole, or we can flip it and write 1 mole over 2.02 grams. This is the mass of 1 mole. So in this case, we have grams on the top, so we need grams on the bottom, so it's going to be 2.02 grams of hydrogen is going to go on the bottom, and the 1 mole is going to go on the top. This is going to allow us to go from grams to moles of hydrogen. But we don't want moles of hydrogen, we want moles of water. So now, looking at our stoich map, we need the mole-to-mole ratio between hydrogen gas and water. So we're going to find that mole-to-mole ratio in our balanced chemical equation. The coefficients tell us the number of moles. So we have 2 moles of hydrogen gas, and we also have 2 moles of water. So now if we go back, we can cancel out our grams of hydrogen, our moles of hydrogen, and we're going to be left with moles of water, which is what we want. So you're going to take 1.9 times 1 times 2, and then divide it by 2.02 times 2. So multiply everything on the top across, then divide by everything on the bottom multiplied together. So that you should get 0.9406 moles of H2O. Please give me 4 sig figs on the stoichiometry problems that we're working. And so 0 is not a significant digit, so 1, 2, 3, 4 to get our 4 sig figs. All right. So now, if you flip the page, we're going to use this same chemical equation for hydrogen gas reacting with oxygen to produce O2 to work this in the next problem. And it says how many grams of oxygen are required to react with 3.5 moles of hydrogen gas. So my number and unit that we're given here is the 3.5 moles of hydrogen gas. We want to find how many grams of oxygen. So if we take a look back here at our mole map, and we mark out where we're starting at. So we're starting at moles of hydrogen. So this is going to be our starting place. And we want to find grams of oxygen. So we're going to go to here. So we're going from moles to grams. So we're going to start with that 3.5 moles of hydrogen. Then we need our mole-to-mole ratio that comes from our chemical equation. So we again have 2 moles of hydrogen. And now we want the moles of oxygen. So we have 1 mole of oxygen. And then we're going to need the molar mass of oxygen. So oxygen's average atomic mass is 16. Multiply that by 2 since we have 2 of them. And that's going to be 32.00 grams per mole. So we're going to put 1 mole of oxygen on the bottom and the 32 grams of oxygen on the top. And if we go back, our moles of hydrogen cancel, moles of oxygen cancel, and we're left with those grams of O2. So 3.5 times 1 times 32, and divide that by 2, you should have got 14.54 grams of oxygen. Okay. So we're going to take a look at a new chemical equation for the next 2 problems. This one says you need 4.8 moles of ammonia. So that's the number and unit we're given. How many grams of hydrogen gas would you need to react with an excess of nitrogen gas? So basically what this is saying is I'm not worried about how much nitrogen gas we have because we have plenty, but I'm worried, will I have enough hydrogen gas to produce the 4.8 moles of ammonia? So 4.8 moles of NH3 is what we're starting with. And so we need to look in our chemical equation. We have 2 moles of NH3. And our moles of hydrogen is going to be 3, so 3 moles of hydrogen. And then we want grams, so we're going to use that molar mass of hydrogen, which we calculated to be 2.02 grams per mole. So then we look back here, moles of NH3 cancel, moles of hydrogen cancel, we're left with grams of hydrogen. If you go back and you cancel out your units, this will also help you determine have you set it up correctly or not. So we're going to take 4.8 times 3 times 2.02 and then divide that by 2, and you should get the 14.54 grams of hydrogen. And I made a mistake here. I was looking at the wrong problem on this last one. This is not 14.54 grams. It should be 56 grams. I'm so sorry I made that mistake. So 56 grams. Okay. Wow. All right. So then our next problem says how many grams of hydrogen gas are needed to fully react with 3.75 grams of nitrogen gas. So we're going from mass to mass in this problem. So we're going to start with 3.75 grams of N2. We need to find the molar mass of nitrogen. So nitrogen's average atomic mass is 14.01. We're going to multiply that by 2. So we have 2 atoms, and we're going to get 28.02 grams per mole. So 28.02 grams, 1 mole goes on the top. So now we need to look how many moles of nitrogen do we have? Well, we have 1 in our chemical equation. And then hydrogen, we have the 3 moles of hydrogen. And then the molar mass of hydrogen, 2.02 grams. So if we look back here, grams of nitrogen cancel, moles of nitrogen cancel, moles of hydrogen cancel. We're left with grams of hydrogen. So we're going to take 3.75 times 1 times 3 times 2.02. Divide that by 28.02, and you should have got 0.8110 grams of H2. Okay. Our next equation says that we have dinitrogen pentoxide decomposing to form nitrogen dioxide and oxygen. And we are given 2.8 grams of dinitrogen pentoxide. We want to know how many grams of oxygen would be produced. So I want you to go ahead and pause the video and try setting this one up on your own, and then come back and check it. Welcome back. So we're starting with 2.8 grams of N2O5. So we need to find the molar mass of this. So nitrogen is going to be 14.01 times 2. That's going to give us 28.02. Oxygen is 16. times 5, and that's going to give us 80. Add these together, you're going to get 108.02 grams per mole. So we're going to have 108.02 grams of N2O5 on the bottom, 1 mole on the top. And then in our chemical equation, we have 2 moles of N2O5. And we have 1 mole of oxygen. And then our molar mass of oxygen is going to again be 32 grams per mole. So if we look back here, grams of N2O5 cancel, moles of N2O5 cancel, and moles of oxygen cancel, left with grams of O2. So we're going to take 2.8 times 1 times 1 times 32, and divide it by 108.02 times 2, and you should get 0.4147 grams of O2. Okay. You have practice F, basic stoichiometric calculations at the bottom of page 6 and the top of page 7. You need to work through those problems for next class. We're going to take it a step further and add in particles next class, so you want to make sure you understand the mass to moles and moles to mass and mass to mass that we talked about today. You also have this book assignment, homework number 2, page 375 through 376, numbers 11 through 13, so 11, 12, and 13, and then on page 378, number 21. Also from your lab, the class action lab where we did those 6 reactions, or you guys did 5 reactions in class, you need to write a paragraph stating which indicator of a chemical reaction you observed in reactions 1 through 5. So say, in my observations, I observed this, that indicates that a chemical reaction occurred. If you have any questions, feel free to stop by and ask me. Thanks. Have a great day. Bye.